All right, welcome to period 4 for statistics. We're going to talk about chapter 20, a one proportion z-test, our first ever test. You'll never forget where you were that first moment you ran your first test right now. And who knows, maybe the next time I check in with you, I'll have a third baby. Woo! Coming up. Let's do this. All right, here are the... What's up?
Are you going on maternal leave?
Paternal from me, but no. The great thing about this school is we don't have any paternity leave.
That's great. Wait,
Sorry.
Wait, then why is Mr. Rose always on maternity?
I thought it was a law.
Always on. He hasn't had a kid yet. What? I don't even know how to answer that.
I thought it was a law.
There's no law in America for parents, for dads. For dads.
I thought you were last.
No, I just take days off. Paternity. We have a clause in our handbook that says paternity leave, and it says you're allowed to take your days off. That to me is not paternity leave. That's called paid time off. So I will probably take a day or two. So next week, if we have the baby, you won't see me for a couple of days.
Oh, wait. You do next week? Oh.
The 23rd, but she's thinking the 19th.
So whenever it's maternal leave, they pay?
No, maternity leave, there's like FMLA, federal mandated leave, something. What?
She can sit down. She can walk everywhere.
No, that's actually better for the mom and the baby is to walk a lot.
I'll be tired.
I'm not saying she's not tired, but we got bills to pay, so she better keep working. All right, so you get like 60% of it's called a short-term disability. They call having a kid a disability. I mean, that's what they label it as. Guys, if we worked for a Fortune 500 company, like if I worked for one of the companies you might work for, right? She might get 4 months off full salary the whole time, but that's rare. Not many in the U.S. Some in the U.S. do. It's rare. Like one of my friends got 2 months off fully paid. A guy. That's really rare. You go to some of like the Scandinavian countries, you get a whole year off. Everybody fully paid. Yeah. That's right. That's why we're all moving there, right?
Yeah.
By the way, it's cold.
I'm
not going. It's too cold. Too cold. All right, now that we've wasted 3 minutes, let's do this. So, here are the things we're going to be teaching you. I'm going to be teaching you over the next 4 days, and I'm so happy because we get 4 full days. I'm so excited to see you guys for 4 straight days. I'm so happy. So, no baby this week. Thank you. So, we're going to talk about a sample statistic provides evidence against a claim about a population parameter using a hypothesis test. I'm going to teach you about 5 of these different hypothesis tests. So this is your first one this week. It's so important that we're going to continue what we do this week into next week. All right, it's so important. We have so much stuff to talk about, so many little nuances that we need 2 weeks for it. We're going to talk about hypothesis statements, what null and alternative hypothesis statements are. Talk about actually running the test and interpreting results. And ultimately here I put at the bottom, you can kind of see those 4 there. Those are the 4 steps I'm going to teach you this week. How to set up your hypotheses, explain what model you're going to use, then actually do the math portion. That's the mechanics. That's like running the test. And 4 is the conclusion, and that's where you're going to explain to me what happened. All right? Are you guys ready? Okay, let's do some writing. All right, so for a one proportion z-test, let's start with the hypotheses. You have 2 hypotheses. The first one is called the null hypothesis. All right? So when you think about a null hypothesis, I want you to think, what is your best idea for the population parameter right now? I'm going to say that again because that's ultimately what the null hypothesis is. You probably don't know what the true proportion for a population is. We probably don't know what it is, all right? But based on what the problem states, what is your best idea for P? And remember, P is the population proportion, all right? So these hypotheses will always be using letter P, the population proportion. Now, the alternative hypothesis is what you're trying to prove is a better idea for a model. All right, so we're going to use the same thing for the null. It'll have the same P, they'll have the same proportion. In our example today, I think it's 0.9. but we're going to have a different symbol. So it could be greater than, less than, or not equal to. That's going to be the alternative hypothesis. The way I think of this is, think about our criminal justice system. All right? If you are arrested and you go and stand trial, what is the null hypothesis about you? What's the null hypothesis about people on trial? I hope not. Wow, we are brutal in here. Not, you're innocent. You heard that phrase? Somebody said it, I think, Brissa. Innocent until proven guilty. Right? So the idea is the null hypothesis, if we're talking about again, I understand there's a lot going on in the world, but if I'm thinking about a criminal justice system that is fair, then I'm thinking that the null hypothesis is that you are innocent, and the alternative is that you are not innocent or guilty. And actually, I don't even think we do that in our criminal justice system. I think we just say, is there enough evidence to say that you're not innocent? I know some people read it as guilty, but basically it's saying, do we have enough evidence against the idea that you're innocent? Okay? That's what the criminal justice system is about. All right, let's move on to number 2, the model. Now, I don't want you to freak out about this. There's going to be a lot of writing, but I've been trying to prep you for the last 2 weeks. All right, when we get to step 2, talking about the model that we're going to use, I want you to think, make assumptions, and check conditions. Make assumptions. And we've been doing this. That's what I'm saying. Like, I hope it will be a lot of writing, but in terms of, it won't be anything new. Right? It's all the same assumptions and conditions. Do you guys remember them? Anybody remember one of the assumptions? The independence assumption, what conditions did I check under that? Randomization and 10%. I love it. You guys remember. What's the other assumption? Sample size assumption. What condition do we check for? Proportions. Ooh, proportions. Nah, not large enough sample condition. Success and failure. Remember, that's where we do the n times p and n times q. So we're going to do that again in our example. Now, I want you guys to see here, if I point this out to you, I think you already wrote it down, but if you look here, do you guys see the notation that I used for the standard deviation? Do you see how that says SD? What did we use last week? SE. Remember last week was SE? Here's the reason we're back to SD. The reason we're back to standard deviation and not standard error is because we are going to assume that our best model is a P equals some number, some proportion. So since we know P, we're going to use standard deviation. Again, the only reason we would not use standard deviation is if we don't know P. All right, but our hypothesis, our null hypothesis, is that P is a number, and that's our best idea for a model. Okay? Now we'll talk about the nuance of that later. Okay, let's keep it going. Here's the mechanics. So this is where we're going to do the actual math. The work that you would consider a math course happens in the mechanics. We're going to list the sample size. We're going to list the number of successes. We're going to list P hat. Do you guys remember P hat? Anybody remember what P hat is? P hat. What is it? And not population. What's the other one? If it's not a population, it is a... No, they're both proportions, but if it's not the population, it is a sample. It's the sample proportion, right? P hat is the sample proportion. From the sample that they're actually giving us that data, that's where we'll find P hat. Then we're going to find a z-score. We're going to draw a curve. All right, as all statisticians do when they do this, they draw their sketch of a curve, and then we're going to shade whatever direction it wants us to shade to find what we call a p-value. I'll explain more in context when we do this, but a p-value is a conditional probability. All right, which I think is what you're writing right now. Basically what this means is if I assume that our null hypothesis is the best idea for what's going on right now in the world, then the likelihood that we get our observed statistic or something more extreme is that p-value. And I'm going to be using that a lot over the next 2 weeks. When you run a test in my class, please always include the p-value. It will allow myself and anyone else reading it to make their own conclusion about the test that you ran. Any questions so far? We got one more step, the conclusion. All right, let's go to the conclusion. All right, so in the conclusion, we're always going to make a statement about the null hypothesis. All right, the phrases we're going to use are going to be, we reject it, or we fail to reject it. We're never going to use, we accept. We're never going to accept the null hypothesis or the alternative hypothesis. We're always going to say we reject it or we fail to reject the null. The idea being, guys, is that we think our null hypothesis is the best idea for what's going on in the world for this situation. If we don't have enough evidence to say that something else is happening, then we fail to reject it. So we still think it's our best model. And as I taught you guys last semester, you know that all models are wrong. But we have, with our null hypothesis, our best wrong model, our best idea of what's happening. So the bottom part there about the alternative hypothesis, these are the options that we're going to use. And it looks really complicated when you're writing this down with all these different parameter, hypothesized value, and symbols. But ultimately, what I want you to think is copy the null hypothesis, and just change the symbol. So the null will always be the equal sign, and the alternative will be one of those other options, less than, not equal to, or greater than. And the context of the problem will tell you which one to use. So there is like a right answer, if you will. I put on the side there, one-sided or two-sided. You're going to see that, not today, but in the future when we do a two-sided test, we're actually going to shade in both tails. All right, with one-sided test, you're only going to shade in one direction. Great band. But with two-sided, you're going to shade both ways, so both tails. Just changes the mechanics a bit. Okay, last slide before we do our example. Let's do it. So this last one, which I don't think of anything to write, excellent, was just talking about p-values again. Please always write it down. Always write down the p-value. I want to see it. I'll be looking for many different things when you do this test, but always will be checking for that p-value. And ultimately, this p-value is going to be what you base your decision on. Okay? So I'll be showing you later on today what it actually means. All right, you ready, guys? You okay, Jalissa? Okay. We ready? Oh, man, I'm so excited. I can't. Oh, man, I'm so excited. Man, I love this day. What a great day. Okay. So you should flip, and just to let you know what's going to happen, the expectation, we're going to spend the next 40 minutes doing the next 3 pages. So there's like 2 slides on each page. All right, so we're going to do the first 2, the next 2. We're going to do 6 total slides in 40 minutes. All right, so almost half this packet you're going to have already finished, which is amazing. All right, so you got to get to that slide. Get to it, Jalen. Woo! All right, let's have Peter. Go ahead and read us this question that we're going to answer today.
A 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. The city's fire department has been running a public safety campaign about smoke detectors consisting of posters, billboards, and ads on radio and TV and in newspapers. The city wonders if this concerted effort has raised the local level above the 90% national rate. Building inspectors visit 400 randomly selected homes and find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate?
Thank you, Peter. I really appreciate that. Now, my first thought is, when I read this, is thinking about my house. All right, think about where you live. Can you think about how many rooms have smoke detectors? No? Do that tonight. See if you can find your smoke detectors. One? Exactly one? Okay. The kitchen? Yeah. Any others? Just one in the kitchen. Okay. Are you worried? It's not in the kitchen. Yours is in the kitchen. But who's in the kitchen with Dinah? Remember that song? Someone's in the kitchen with Dinah. Yeah. I'm old. You have no smoke detectors. Yes, yeah, I think so. You look tonight. See if you find them. They have like a little. No. You took them all down. I understand when they beep, that's annoying, but I would also really recommend going to Target or Walgreens or Walmart or CVS, getting the batteries and replacing them, because when you're dead, it won't really help you. Right? We've all seen This Is Us, okay?
Oh my God, you guys don't talk about it because I haven't catched up.
Okay.
She just said yes.
Let's go ahead and start by something that I call defining. I'm not going to spoil anything because I was just yelled at, so I'm not going to keep talking. I'm not going to keep talking. If you want to catch up, start season 1 tonight for This Is Us. Okay, the first thing we're going to do is we're going to write a sentence that's called defining the parameter. It's not right now, Peter. Not right now. We're not watching TV right now. Okay, so let's think about this. The parameter is a population proportion. Okay, the population proportion. So let's say right here, let P represent. Now let's think about this in the context of what Peter read for us. For a population proportion and the test we're going to run, what do I want P to represent? What's my population? Now, my population is not 400 homes. That's my sample size. 376 is the number of successes in our sample. So you could say American homes, but where are they doing the ads? Where are they doing these advertisements? Right, I'm thinking posters, billboards, ads on TV, radio, and the newspaper. I'm thinking Houston. I'm thinking local, like the city of Houston. So what I'm going to write is, let P represent the proportion of all Houston homes with at least one smoke detector. How do we feel about that? So we're saying the population is Houston homes. Okay? The population is Houston homes. Everybody good with that? Now, do I know what P is? Do I know right now, if you think about not just your house, not just your friend's house, not my house, all Houston area homes, do you know the proportion of all those homes that have at least one smoke detector? No, right? And it would take you a lot of money, time, many days, probably weeks, months, to actually go into every house and do this, right? Right? It's not really possible. It's not really feasible. So we have to think, what's the best idea for what we think it is? So based on what we read, it says 90% of all American homes have at least one smoke detector. So for the null hypothesis, right, for the hypotheses now, if I write down the null hypothesis, which is H sub 0, that 0 is a subscript. It's not H2O. H sub 0. I'm going to write P equals 0.9. My best idea for the proportion of all Houston homes that have at least one smoke detector is 90%. That's what I think is the best model. Is everybody okay with that? That's what we think is the best model. Okay? Now, for the last let's say that for the last 6 months, they've been running this campaign on TV ads, radio ads, newspapers, billboards, posters, whatever, where they're trying to get people, like as I just polled the room, to put more smoke detectors in their house to help them in case of a fire. Okay? So for the alternative, which is another H, but this time we do subscript A for alternative, here's why I want to make sure you understand what I'm doing here for the first one. What I tell students is to write P and write your proportion. That should always be the same. But what's going to change is instead of equal, we're going to write a different symbol. So we have options here. We have less than, greater than, or not equal to. So what do you think we want to put based on what it put up there in what Peter read? So do you guys see this part here where it says, where is this strong evidence that the local rate is higher than the national rate? So I see that higher word, and I think what? Greater than. So I'm going to put greater than. Basically, we're saying, is there enough evidence to tell the people that have been running this campaign, hey, it's working. The rate is higher than 90%. That's what I want to find out with our test. Is there enough evidence to tell them, hey, your effort of these ads, billboards, it's working. We think it's higher than 90% now. Okay? Everybody good so far in the hypotheses? Did you guys see that other step here? Defining the parameter? You got to make sure you do that first before anything. Okay, that's step 1. Yes. So here's the great question, Susanna. If you do this part, define the parameter, no sentences needed, just symbols and numbers for the hypotheses. If you don't do this part, you got to do sentences. So that's why I do this part, because then I like symbols, personally. Okay, but it's okay if you wanted to write null hypothesis. The proportion of all Houston homes with at least one smoke detector is 0.9. Alternative hypothesis. The proportion of all Houston homes with at least one smoke detector is greater than 0.9. You could write that too. That's fine. I think it's more writing. So, all right. Step 2. The model. All right. What are we going to do when we get to step 2? Not draw the curve yet. We're going to draw a curve, but not yet. Assume assumptions. That makes sense to me. Let's make assumptions. What's the first assumption that I'm going to make? Independence. Assumption. Who wants to give it a try? Who wants to give it a try and make a statement that assumes independence for this problem? Because remember, I'm not writing a sentence, but you should be. Anyone? Well, let's just give it a guess. Jalen, yes, thank you for volunteering. What do you think, Jalen?
One American woman economic regarding smoke detectors.
That sounds good. The only issue I have with that answer, Jalen, or the only thing I would change really is this problem. What am I focusing on? I'm focusing on Houston. So I would probably change Jalen, instead of American, I would write Houston. One Houston home having smoke detectors or not is not going to affect another. Everybody good with that? Again, it doesn't need to be exactly word for word like that, but something to the effect of, if you walk into a home and you count 1, 2, 3, 4 smoke detectors, and then you randomly go to the next one, it should have no bearing on what you just did. Now, do I know if that's true? I don't. So what do I check to make me feel a little bit better about making that assumption? Randomization. When Peter read the problem, did it say anything about taking a random sample?
Yes.
It did. It said they randomly went to 400 homes. All right? So you want to make a statement about your sample size of 400 homes is a random sample of all Houston homes. Something to that effect. End of class. Come back at the end. Like 9:30, like right before class. Yeah, because I'm in the middle right now. Thanks, guys. So popular. Just want my autograph. I can. We're saying that 400, I think it's right here, Galileo. 400 homes were randomly selected. All right? Randomly selected 400 homes. Sorry, I'll go back. Yeah, you're basically saying, like, I don't know if each home is independent of the next, but if they do a random sample, that makes me feel good because then they're not like only in one neighborhood or only in one part of the city. If they're doing randomly 400 around the whole city, I mean, there might be only one in Kingwood, all right, or one in Katy, or one in downtown. I mean, I'm talking about Greater Houston, right? You, if you don't, fine. Then you're saying, okay, like just in the loop or like just outside the loop. All right, there's only one in Sunnyside that they're looking at. There's only one in. So many autographs. Hey guys, I'm in the middle of teaching, so can you come back like right before like 9:25? Thank you guys. Sorry. Okay. What's the other condition that we check to make sure that we feel the 10% condition? Okay, this one I did teach you to do some math with for the last couple of weeks. We start with our sample size of n. What is our sample size? 400. What did I teach you to do with that 400? Times 10, and that gives you 4,000. All right, now we're thinking about the Houston area, the greater Houston area. Are there more than 4,000 homes? Absolutely. Okay, so what that's saying, the statement you should be writing is our sample size of 400 is not too large. Our sample size of 400 is not too large. So again, that's the idea. If you think they're more than that number, then our sample is not more than 10% of the population. I always think back, if you're having trouble with this, always go back to this school. How many students are there? 550, about, give or take, right? 550. All right, so 10% of that is 55. So if you're sampling more than 55 Cristo Rey Jesuit students out of that population, then your sample size is too big. All right, so you really want sample sizes of less than 55. So think about the students. All right, is that helpful? Maybe it's not. All right, that's how I would think about it. Okay, what is the other assumption we're going to make? If we just said the sample size is not too large, we need to assume that it's large enough or not too small. So that's called the sample size. I'm still recording, yeah. I mean, it's in my profile that I'm a teacher at Cristo Rey Jesuit. Are you worried about Julissa Garcia in period 4? Oops. Yeah, I'm recording. Hey, no one watches it. You're all good, man. Sylvester, there's a little too. Your laugh was a little too hurtful.
I didn't know that they delete our accounts. What? That's why we subscribe because they delete our accounts.
Oh, so you need to subscribe with like a different email. I see. That's why I can never stay over 100. Man, see, this is the fight, man. This is the fight I'm in. Trying to make that money. Okay. They give you, okay, so they give you a few months into college? Okay. They ask you for, maybe you get a school email for like your college, or they'll ask for your personal email. Just get a Gmail. Just do gnunez@gmail.com.
No, who was trying to cancel my own Gmail? It's supposed to be I'm just like, someone have to make 2 new ones for the school.
Do you open your Gmail every day on your phone?
I do, because mail comes in, but they're like, oh, you're not using it that much, and due to like the law that they have or whatever.
Huh, interesting. Somebody's trying to get at your email. Yeah. Sad. Okay. So we're assuming that 400 is large enough. What do we check to make sure that that's true? Now that's for means. We're going to get back to that, right? Don't you forget about me. That's going to be after spring break. Did you die? What? How did you die? But you just said I'm dead. I'm so confused. Now I'm dead. This is craziness. Success failure condition. Is it because I just started singing? Is that the problem? Oh, thank you. My daughter really likes my singing, so I sing a lot. Okay. Yes, the sample size of 400 is large enough. Now we're checking to see if we're, speaking truths here. So I need to do n times p and n times q. This is for success and failure, yes. Okay, what's our sample size? 400. Now listen to this question. What is the proportion of all Houston homes that I think owns at least one smoke detector? 0.9, right? So make sure you're using your null hypothesis P here. So 0.9. Do you guys see how what I wrote down is P and not P hat? So that's a difference. So make sure you understand that is important. Okay? And then 400, what is Q then? 1 minus P, so it would be, I think Jalen said it, 0.1. So let's do this quick math here. What's 90% of 400? Excellent, 360. And what's 10% of 400? 40. You guys see how these two add up to 400? That should always be true, right? Should add up to your sample size. So, when you look at those two numbers, are they both 10 or higher? Yes, so basically this is saying what I just checked is that my sample size is large enough. We have more than 10 successes and failures. Okay, we've reached that moment where we're almost done with step 2. Does anyone know the statement we're about to write? The conditions have been satisfied. So I will use the normal model, run A, one proportion. Now, okay, that's not a 2, that's a Z. One proportion. Now, we're not running an interval, right? I told you this is going to be a test. With intervals, you don't do hypotheses. I'll say that again. With intervals, you're not doing hypotheses. Okay? So whenever you're doing hypotheses, that means it's a test. So one proportion Z test. Okay. How we doing? Everybody good out there? Right? If you're doing well and you're watching, go, woo! You're not watching. When you watch later tonight, you'll woo. No, not later tonight. I don't know what is the problem. Who gets worried? Why does your mom get worried? When you woo in the house? Yeah. Because you're having too much fun? No, that's not what I'm... No, don't watch it at 1 in the morning. Watch it at 8:30. Man, you should be going to bed before tomorrow. Okay, that's what I'm... Okay. Let's get to the math. We've made it to the math.
Is that all you do?
Well, I mean, we're still doing the problem, right? We're on step 3. We just finished the model. Now we're going to step 3. Mechanics. This is the math. If you want to write mathematics, this is what we're doing. All right? So this is where I write down my stuff. So write down N. Write down N equals 400. 400. Okay. This is where I'm going to write a normal x. So that's just a lowercase x. I don't want you to think it's capital, it's a lowercase x. This is what I'm calling my successes. You have to actually go back to the problem. I know it's a couple pages ago, but when they went to those 400 homes, how many had one or more? 376. Very good. Okay, so then after this, I should be able to write my p hat, which is my sample proportion. What fraction am I going to write down? 376 over 400. Very good. So you should take your calculator out right now if you have one near you. All right, Galilea's got 2, so if you need one, talk to her. She's also got 2 in front of her, so she's got all the calculators. Good job, Peter. Thank you. Thank you, Julissa Garcia. Can I have a calculator? That was so funny. You were so quiet about it. Give me a calculator. Peter, don't throw them. Don't throw them. Don't throw them. That's like one of the rules, right? Don't throw things. Don't woo at 1 in the morning. Okay. What is 376 over 400? Very good. Okay. Now we're ready to do our math. I'm going to write down the formula. Z equals, we're going to find a z-score, right? This is a z-test. Z-score. All right? This is where you're going to put your statistic minus parameter. Now that doesn't mean much to you probably. The statistic is p hat. So statistic minus parameter. Anybody know what the parameter is? Very good, Yasmin. Over. This is the standard deviation. All right? But here's what I'm going to write. I'm going to write standard deviation of p hat. Now, do you see that I put standard deviation as SD, not SE? That is important. That should be SD in your test. Because right now, our best idea for the proportion of all Houston homes that have 1 or more smoke detectors is P, or 0.9. So that's why we're still using SD. All right? Just out of curiosity, does anybody know the formula to the SD, or standard deviation of p hat? Square root of p. You can write sub-zero, that's fine. Over n. The reason I don't is because if I just write p and q, that's population parameters. If you write p sub-zero, that's basically saying look in your null hypothesis. That's what they're trying to do. All right, but you only need to write p and q. Everybody good? Okay, so let's plug in our stuff. Should I use purple again? Or do you want me to use a different color?
Green.
Green? Okay. So, equals. What is p hat?
0.94.
Very good. 0.94. Minus p. 0.9. Over the square root of 0.9 times 0.1 over 400. So whatever that is equal to our z-score. So z equals. Now, right now, if you have a yellow calculator, you should be able to use your like N over D buttons to just plug this in all at once. All right, but I'm going to show you later today before we leave. Maybe not. I don't have enough time. But I'm going to show you. There's a website we can go to get everything. All right, I'll show you. Okay, so we have N over D 0.94 minus 0.9 over. It's a square root of a fraction. 0.9 times 0.1 over. Does everybody have their number? Yes. Oh, I did over 40. Man, I'm so stupid. What is it? 2.6 repeating, exactly. Okay, so 2.67. Okay. Everyone okay with this so far? Okay, I want you to take out your cell phone. I'm going to send you an email to your school email. All right, here it comes. Okay, what are you guys? Period 4. So 1 proportion z-test. What's up? Okay, there you go. You know, Yasmin, I'm nothing if not fancy. Let's just say that right now. Okay. So you should have an email. Click on it. It'll take you to this. Zoom in for you. Yeah, it's Math Cracker. Listen, I don't name it. Also, there's going to be ads on this page. Don't click on the ads. I shouldn't need to tell you that. No ads. Okay, don't click. All right. Should I count to 30 and then we'll all be here? Okay. P. What did we use for our null? For our null, Susanna, for our null. Equals, right? What did we use for our alternative symbol? Greater than. If you don't want to do this right now on your phone, that's fine. I will use Chromebooks or laptops tomorrow. You can just watch if you want. It's up to you. Whatever you want. What is our P, our population proportion? 0.9. What is our sample size? 400. What is our number of successes? 376. Now, do you see where it says significance level? Until I tell you otherwise, I always want you to use here 0.05. So 0.05. And I'll explain that more next week. All right, but for now, just put 0.05. Scroll down. Don't hit Penn State World Campus or whatever yours says. Hit solve. Yes, and we're going to hit solve. Hit solve. The suspense is killing me. Come on now. Come on, computer. Come on, computer. Math Cracker, come on. Well, this is disappointing. Yes! Yes! Okay, now, take a look. Do you see step 1? Oh, look at that. There's our hypotheses. Nice. Now, do you see, I know, right? Do you see step 3? Where it says test statistic, that's our mechanics. Do you see our z-score? Okay, now, I'm going to come back to this, but I want you to go back to your notes, and I want you to go to the next blank page. So you should just, on the same page, but just below it, I want you to write down, okay, we're going to write down our curve. All right? So draw your curve. Wow. Nice work. Okay. Where is z equals 2.6 repeating? Is it in the middle? No, middle should be z equals 0. And the middle is z equals 0. So where's 2.6 repeating? To the right. Pretty far near the end, right? Because we've said in the past that your 3 is going to be almost near the end. So let's put it here. So that's z equals 2.6 repeating. And which way am I shading? What was our symbol in the alternative hypothesis? Greater than, so to the right. So the question is, what is the area that I just shaded? Do you see that? I'm drawing an arrow to it. What is that area, that value, as a proportion of 100% or of 1? What is that area? If you go back to your phone, or if I go to my website, I will see that it gives us, do you see where it says using the p-value approach? The p-value is p equals 0.0038. That is the shaded area. So I'm going to write down p value equals 0.0038. 0.038. Okay, now I'm going to say a few things before we ultimately do our conclusion. First thing I'm going to say about a p-value is, what did we think our best value or our best proportion was for all the Houston homes that have one or more smoke detectors? What is our best idea right now? 0.9. Okay, so if I assume that 90% of all the Houston homes have at least one or more smoke detector, this is important, so really listen to this. This is the first time you're going to hear it, and it's going to be many times. If I assume 90% of all Houston homes have one or more smoke detectors, the likelihood that I would see 376 or more out of 400 that have one or more smoke detectors is 0.0038. So when I say that statement and you ask yourself this question, how likely is it that we're going to see 376 or more out of 400? Look at that number. How likely is it? Not likely, because this is close to 0. It's close to 0. So the reason that I brought that up is for our conclusion statement. So I want you to go to the conclusion page. You got to flip it over. Conclusion, yes? All right. This page here. Okay. Since the p-value is so low, I am going to reject the null hypothesis in favor of the alternative. Now I'm going to let you write that down, and while you're writing it down, I'm going to say, as you're writing that down and reading it, is there any context to my answer right now? Do you see any type of context about homes, smoke detectors? Nothing, right? It's just straight up generic as possible. Low p-value, reject the null. All right, so that's one thing you're going to learn in your brain this year as we finish this semester is low p-value, reject the null. It's not our best model anymore. All right, our p-value is close to 0. That's really unlikely that we would have seen 376 or more out of 400. So it's better to say, you know what? 90%, that's not my best model anymore. Now, what is my best model? And this is where students always mess up, so be careful. Now, what am I going to say is the best model for Houston? Well, what was the other hypothesis? Not that it was 90, but that it was greater than 90. All right, so that's the second statement you're going to write down. There is enough evidence to report that the proportion of all homes in Houston with at least one or more smoke detector is greater than 90%. Now, I know I'm typing this, so obviously I type much faster than you can write, so I apologize. But the reason I want to type it is that you can see how clear I am about my two things. The first sentence, super generic, I made my decision. I'm rejecting the null in favor of the alternative. All right? Second sentence, I put into context what that means for the problem that we just did. Basically, I'm saying what about those advertisements? What am I saying about the billboards? What am I saying about the posters, the ads on TV, the ads in the newspaper, the ads on the radio? What am I saying? It worked. I'm saying it worked because now I think Houston, their rate of smoke detectors in homes at one or more is greater than 90%. So I'm saying it worked. Now, we don't have enough time to do this. But I just told you that the rate of homes in Houston that have at least one or more smoke detector is greater than 90%. Does anyone have a question in their brain that's like, okay, you're telling me it's greater than 90%. What's the question that I have in my brain then? No, that's the p-value. I just told you that it's greater than 90%. So what's the next question? Not how likely. We said how likely in terms of the, what is it? Oh, I know because of the test, right? P-value is so low. So I'm saying it's greater than 90. So now the question is, if you tell me it's greater than 90, how much greater than 90%? And if only there was a way we could write down with a level of confidence what the proportion would be. So tomorrow, we're going to start class by doing a confidence interval. Yay! All right. Thank you for watching. I know this is a long video with lots of sidetrack detours about paternity leave and about Jalissa Garcia doesn't want to know that she's in this class right now. But anyway, and your email's being terminated. This is a really important video to watch about one proportion z-tests. Hope you enjoyed it. Like, subscribe. And if you ever want to come visit, just make sure you go to the office first, get a pass, come on by, you can watch it live. All right? I love live audiences. Oh, no. I got to hit stop. I would have said...